Hello everyone. Let's understand how to derive the first equation of motion with graphical method. To derive first equation motion, that is v is equal to u plus at, we will use velocity time graph. We will consider the object moving with uniform acceleration. So, look at this graph. From this graph, you can see that initial velocity of the object is u. This is u. And this initial velocity of the object is at point A. See, we have taken this point A because it's not starting from 0. So, from this point, the velocity is increasing. Then, the final velocity is at point B. See, the velocity changes at a uniform rate, and that is A. Look at the slope. It is going upward. So, here we can say that velocity changes at a uniform rate A. Now, from this, what we will do is, from point B, we will draw perpendicular lines on time axis and on velocity axis. So, it will be like this. Now, here we can say that OA is initial velocity. So, this is initial velocity. And BC is final velocity. The reason is simple. We know that final velocity is initial velocity plus change in velocity. So, if you can see here, OA is initial velocity. And this OA is equal to DC. Right? And this is the reason that BC, which is final velocity, is equal to DC, that is initial velocity, plus BD, that is change in velocity. So from this, we can say that BD is change in velocity. So, what we can see is initial velocity is u, that is at point A, because from point A, the object starts moving with a velocity. Then, final velocity, that is v, that is at point B. The velocity changes at a uniform rate A. Then we drew perpendicular lines on time axis and on velocity axis. On time axis, it is BC, and on velocity axis, it is BE. And all these things are happening in the time interval T, that is OC. So here, this OC is time interval. Now, we have seen that change in velocity is actually BD, because change in velocity is final velocity minus initial velocity. So here, this change in velocity is actually final velocity minus this initial velocity. This is initial velocity because dc is equal to OA, and we know that OA is initial velocity. Now, what we will do is we will draw parallel lines, that is AD, which is parallel to OC. So here AD is parallel to OC. We can see this. Now, from this graph, we can see that this BC is equal to DC plus BD, right? So, from this we can say that BC is equal to DC plus BD. We know that BC is final velocity and DC, which is equal to OA, is initial velocity. BC is final velocity and DC, which is equal to OA, is initial velocity. And this BD is change in velocity. Now, recall our formula of acceleration. Acceleration formula says that A is equal to change in velocity upon time. From this, I can say that I want to find out change in velocity. So, this time will change its side and will come here on the LHS side. With that, we can say that change in velocity is equal to A multiplied by T, that is AT. And now, this BD, which is actually a change in velocity, will be replaced by AT. So, here you can see that V is equal to U plus AT. Thus, from this graph, we can prove that V is equal to U plus AT. This is our first equation of motion. So, from this graph, that is velocity time graph, we can prove the first equation of motion.